Okay, question 2a. So suppose that P diagonalizes A and the corresponding diagonal matrix is D. Okay, prove that for a positive integer n, so for any positive integer n, a power of n is this. Okay, so this is the thought process. Okay, so what we know is we know P diagonalizes A. Okay, and the corresponding diagonal matrix is D. Okay, so it means that we know that there is P such that D is equal to P inverse AP. Okay, then we want to show A to the power of n is equal to P to the power of P times D power of n P inverse for any n positive integer. So for n from 1, 2, 3, and so on. Okay, we'll prove this by induction. So 2a, we first prove that for the base case, which is when n is equal to 1. Okay, for this we sort of want to show A is actually equal to P D P inverse. But this is quite straightforward because we have D is equal to P inverse AP. Okay. Then I can multiply this D on the right with P, so I will have P inverse AP, and I can also multiply P inverse on the right of D, so I will have this. And this is just identity matrix. This is also just an identity matrix. So this means A is equal to P D P inverse. Okay, so for the base case we are done. Now we suppose that A to the power of n equals to PD and P minus 1 is true for n is equal to k. K is more than or equal to 1. Okay, we want to show that it is also true for n is equal to k plus 1. Okay. So we have A to the power of n is A to the power of, for n is equal to k plus 1. Okay. So for n is equal to k plus 1, so A to the power of n will be A to the power of k plus 1, right? Okay. For induction, okay, we need to use this. Okay, we need to use this. Okay, so This actually means that a to the power of k is equal to pd power of k p inverse. So I know how to express this a to the power of k, right? So what I need to do here is I try to make a to the power of k come out. But it is very easy. I can just split a to the power of k plus 1 into this. And now I can write a to the power of k in terms of this p d to the power of k p inverse. And what is a? A is just this, right? p d p inverse. p d p inverse. Okay. And by using the property of matrix multiplication, I can multiply these two first. Okay, and this is just p inverse times p, so this is I. So I'm left with p d power of k d p power of minus 1. And then I can multiply this d power of k with d. I will get p d power of k plus 1 p power of minus 1. And this is p d power of n p inverse. Okay, so it also holds for n equals to k plus 1. So by induction, by the principle of induction, a to the power of n is equal to pd of n p minus 1 for n starts from 1, 2, 3, and so on. Okay, yay, we are done. Yay. Okay, hope it is clear.